going to see the Docker image layer and build cache. First of all, let's do a quick revision. Last time we have seen whenever we build an image, what are the things happens internally. So in between that process, we have seen that it is creating some layers, right? So what is this layer and all we'll get to know in this video. Suppose that this is our Docker file. When we run this command to build an image, Docker did not create one huge file. Instead of that, it creates multiple layers. What is a layer? Think of layers like transparent sheets stacked on top of each other, just like entry point one layer, then under that copy app dot jar, this is another layer, then working directory, another layer, and Java 21 base image. This is another layer. So this is stacked on top of each other. We can think like a layer like this. Every instruction is a layer, and together they become the image. Every instruction create a layer. Consider you are having a Docker file, and the Docker file contains this. Don't worry about the commands. Just think these are the contents inside your Docker file. Now when we run the Docker build, what it will do, it will create the first layer from Ubuntu. So this is going to be our first layer. Now the layer 2 will be this one. Layer 3 will be this one. So every instruction creates a separate layer. In this instruction, how many layers will be there? Total 5. 5 numbers of layers will be there for this Docker file. Why we need the layer then? Let's take an example of Spring Boot application Docker file and we'll understand why we need the layer. Suppose this is your Docker file for your Spring Boot application. When you build the Docker file for the first time, what are the things will be happen? It will download Java, right? Then it will create app. Then it will copy the jar. Then it will go to the entry point, right? And suppose that to build this application, it take 25 seconds. Now you have modified your Java application. Modify something in your Java class. Now you have to rebuild it again. This is for the first build, and if you want to build it again, assume that second build. We have 4 layers for this application, right? So for the 4 layers, it will check the layer 1, downloading the Java. So this layer, no changes. Then it will move to the layer 2. No changes means it will reuse that. Then it will move to the second layer and it will check whether any changes has been made in this layer or not. Second layer also no changes. So it will again reuse that. Then copy layer, the layer number 3, where we are copying the application. So the application has just jar file has been changed because we have modified some class. What it will do now? It will only change here. Made the build for this one only, this layer only. Layer 4 entry point. So the entry point also same. It will use from the previous build. How it's remember what are the operation has been performed in the last build. So now it's called the build cache. It has saved information from the last build and it will check in the new build whether it is changed or not. If it is changed, then it will rebuild. If it is not changed, then it will reuse from the cache. So the reuse is coming from the cache. Now only one layer need to be built, right? So it will take less time. Before it was 25 seconds. Now assume that it will take only 3 seconds. This much of difference will come from this build. That's why we need the layer. So what is the build cache means? Saved information from last build. Now we will see what breaks the cache. Suppose that instead of writing the copy target user service like this, just you wrote for this, what will happen? Anything change in your application, right? In the jar file, you don't have the readme md and all. But if you wrote like this means it will check all the files inside your project like readme.md, what is git ignore, everything it will change, it will check, and if any of them are made any changes, it will rebuild it again. And after the copy also, whatever the instructions are there, it will rebuild for all of them. And these things will make the build slow. So that's why this is not a good practice to write like this. How a bad Docker file looks like from something. Then here copy. This means you have to check all entire project to check whether any changes has been made or not. But for a good Docker file, you always have to write like this target the jar file. So this will not make the cache break and rebuild everything after the copy instruction. And we use this because most of the time the poem.xml don't have any changes rather than a normal class inside a Java project. How cache behaves? Suppose that you have pom.xml for the first build. You have pom.xml, it's build. The src, it's build. Now in build 2, you have modify user controller. Now docker c pom.xml, it's cached. Then it will go for the dependency. It's also cached because in the build number 1, we have already done this. Then src, it's change because we have changed the user controller, right? So it will compile again. This is the behavior of a Docker cache, and it will skip all the downloading dependency and save lots of time. Why do company care about these things? It is only saving some seconds, right? 2 seconds, 3 seconds, or 5 seconds. Imagine you are having 100 developer, then they are doing 20 builds per day. If one person is doing 20 builds per day, 100 people will come to 1000 builds per day. Now, if each build have 30 seconds, assume that for caching it is saves 30 seconds. So over 60 hours of build time will be saved in a day. When we try to build any application for the second time, we can clearly see it is using the cache. We'll see these things when we will do the practical for a Spring Boot application. Sometimes we want a completely fresh build. For that, we have to disable the cache, or else again it will use whatever the cache has been saved. To do that, we have a command docker build no cache -t your user service 1.0 dot. So these things will disable the cache, and every time we will build, it will not use the previous one build cache. We will see some production best practices. First, instructions that rarely change at the top. Which files are rarely changed? That instruction will keep on the top. For example, from place Java 21. This instruction will keep in the top because these things always we need, right? Even though later on any code has any cache has been break, so this cache will be still safe, and we should copy the dependency file before application source code. For example, copy src rc. So before this code, we have to copy what are the dependencies, like copy the form.xml, run the dependency. So next time this will be cached, so only the source code will change and it will break. The later on whatever the instruction, it will only rebuild again instead of rebuilding this form.xml or any dependency. The next best practice is rebuild only what changes. Rebuild only what changes.